In this video, we are going to look at another example for point estimation. So in this example, we are going to consider two thumbtacks, thumbtack T1 with a probability of landing heads equal to theta, thumbtack T2 where the probability of landing heads is 2 theta. And like always, to estimate the probability, we need to collect some data, right? So we are going to use maximum likelihood to estimate the probability of landing heads of both these thumbtacks. And to do that, we need to first gather some data. So we are tossing T1 and T2 to 3 times each, and then we record what we get. So when we toss T1, we first get tails. T2 we get heads, T1 we get tails, T1 again we get tails, T2 we get heads both times. So that is our data set. So we gather this data by tossing T1 and T2, and we are going to use this data set to calculate the likelihood and the maximum likelihood estimate of theta. Now, the first question is, what is the likelihood of the data given theta? So what is this quantity? This quantity is nothing but P of D given theta. So likelihood of the data set, the data that we have seen, this, given that our parameter is theta. Now, what is the likelihood of each of these occurrences? So for T1 to land tails, it is first 1 minus theta. For T1, the probability of landing heads is theta, right? Now we get tails, so the probability of landing tails for T1 is 1 minus theta, right? I'm just going to write this below. Okay, T2 landing heads. We know that the probability of landing heads for T2 is 2 theta. Now T1 again lands tails, 1 minus theta. T1 again lands tails, 1 minus theta. T2 heads, 2 theta. T2 heads, 2 theta, right? So these are their individual probabilities. And now this whole data set occurs at once, right? So we have this entire thing occurring, which is the joint probability of all these occurrences, which then becomes 3 occurrences of 1 minus theta and 3 of 2 theta, which is 1 minus theta raised to 3 and 2 theta raised to 3, right? Now, it's customary to use log. That just helps us in simplifying our calculations. And it's a very useful tool, so don't forget that. And that makes all the difference between computing the answer and not understanding what to do next. Because you will get a really complex polynomial if you multiply this. But if you take a log, it just simplifies your calculations. All right, so we have this expression here for likelihood. We take log and then it becomes log likelihood. 3 times log 1 minus theta, because log of 1 minus theta raised to 3 becomes 3 log 1 minus theta, plus 3 log 2 theta. Now 2 theta actually is a multiplication. We can just write it as 3 log 2 plus 3 log theta. And we'll see how that is relevant just in the next step. Now we have this MLE calculation in the next step. So in the next step, we have derivative of the log likelihood of theta. So to calculate the MLE, we differentiate with respect to theta. Set it equal to 0. Solve for theta. So this is our general approach, right? Now we have minus 3 by 1 minus theta, differentiation of 3 log theta, 3 log 1 minus theta, the first one. The second one is 3 by theta, or if we have 3 log 2 theta, then it becomes 6 by 2 theta. That becomes 3 by theta. So this is anyway a constant, so we can ignore this. We can just use this, and that becomes 3 by theta, right? 3 log theta is 1 by theta, differentiation 3 by theta. So now solving for this equation, we get theta is equal to half. We have a simple equation. We can set it equal to 0, take 1 to the other side and solve for it, and we get theta is equal to half. And now we have solved this problem. So remember to first start with constructing the likelihood, and always remember to use logarithm. It simplifies the calculation. And then for MLE, the steps are differentiate with respect to the parameter, which here is the theta, set that equal to 0 and solve for theta. And once you solve for theta, you report that value as the maximum likelihood estimate. Hope this helps with solving point estimation questions.